Okay, HNC Dimensional Analysis. I first came across this when I did a degree in mechanical engineering, and I didn't have a clue what was going on. But then I realised sort of later into the course that actually I've used this before. So I kind of used it to check that the formula are correct. Sometimes the formula might be a load of rubbish. So one aspect of dimensional analysis is that you can check that. You can check the units, the dimensions of something, okay? So you've got your base units, maths, length and time. A lot of things, equation formulas and so on, comprise of them. So this first video then is showing what are the dimensions of something called the Reynolds number. So the Reynolds number is a way of measuring, predicting when fluid going through a pipe or something goes from laminar flow, which everything is in like layers, laminars, parallel flow like that, to eventually turbulent flow. Okay, and this will also affect friction, things like drag, stuff like that. Okay. So not so in my experience, first of all, fluid mechanics is where I first saw this. Right, so we're proving basically that the Reynolds number is dimensionless. Before I do that though, give you an idea of what we mean by that, because what can that mean? So here you've got a roof, it's got an area of 6 by 4, it's going to have an area. You're going to put tiles on the roof. So if you calculate that, you sort of divide how many of these tiles into that. So the answer you're getting isn't meters squared, it's like a ratio, isn't it? Number of tiles. Similarly with a rope. So your rope is 30 metres long, coiled there, you can see. You want to cut it into half-metre bits. So if you want to know how many bits you can cut it into, you divide. So again, you get like a ratio answer. And this could be anything really. So if you're in the brewing industry, you have something called specific gravity. So that's the density of something divided by the density of water. So dimensionless means basically there's no units. Right, so we've got an equation here, a bit small there, so I might rewrite it. So the Reynolds number, which hopefully is going to be dimensionless, is rho, blown over P. That's the density, times V, which is velocity, times D, which is diameter of your pipe, divided by that Greek letter there, I can't remember what it is, dynamic viscosity of fluids. So viscosity is like the thickness of fluids. I think of golden syrup, very viscous, water not so viscous. So normally I do it as that actually. Okay, so if you want to, you can look up what that Greek letter is called. I've forgotten. Right, anyway, we're now using this table that I've got off the internet. So your base units are mass, length, time. That's what MLT stands for. So you look up rho, density, that is here. M, L, minus 3. Okay. V is my velocity. So that's an L, T, minus 1. So I've done those two. D, that's it's a length. And finally that thing, dynamic viscosity, is there. Sorry to raise that there. Just got away there slightly. So that's M, L minus 1, T minus 1. So you might be thinking, what are these? So that's what, per unit time, yeah? Divided by length cubed. Right, so what I do now is looking at indices. So we'll do M first of all. I just spotted something. We're dividing by this, so we need to do a reciprocal of this last bit and put it in a bracket. Reciprocal will mean 1 over, so you need to change that to a minus 1 there, that to a plus 1, and that to a plus 1. Okay? Okay, now look at indices. So there, we've got an M, there's a 1 there really, and M to the minus 1, so they cancel out. So the M's have gone. Let's do L's. So here I've got L minus 3 and L1, that's now L minus 2. But I've got an L1 here and an L1 here, so minus 2 and 2, so all those L's have cancelled out. Yeah? Finally, you can see you've got time divided by time, or add those in C0, they cancel. You can see the result is the Reynolds number is dimensionless. I hope you spelled that right. Dimensionless. Yep, okay, that's that.